Welcome, STEMgineers, to STEM to Stern, the podcast where curiosity meets critical thinking. Join Chauntée and Jake as they discuss STEM topics that spark debate and exploration.
Welcome back, everybody, to STEM to Stern. This is Chauntée.
Hey, and this is Jake.
Today, we are talking about whether or not you can break time like Loki.
And by Loki, we are referring to the god of mischief, Thor's brother. We are referring to specifically, I'm referring to the show and the concept of traveling through different time variances.
So this is like his adventures with the TVA and the multiple timelines.
The multiverse, aka Doctor Strange. So you think about all of this happening. So for me, I have to remind myself that these concepts came through some scientific concepts that they took and made it more science fiction-y, right? So like the concept of wormholes is still in discussion and scientists are still talking about that.
It's still theoretical. It's theoretical at this point. We've never seen wormholes in nature, nor have we made them ourselves. So it's theoretically possible, but maybe wormholes would allow you to move not just through space but through time too,
Which
to
would be
like other
amazing.
parallel timelines, like Loki.
Right.
Like
Who's to say?
I think it'd be a lot easier just to have those little stick things, and then
Of
just
course.
wham, I'm
Done.
there you go.
I mean, also, I think about like Einstein and his theory of relativity. Like you think about that, and then the concept of the astronauts on the International Space Station.
Very good example there. So like in terms of like parallel universes, parallel timelines, like within real life physics, we have things like quantum mechanics. We talk about things like the mini worlds interpretation of quantum mechanics, where that involves the multiverse. And then Einstein's theory of relativity is also kind of relevant to that idea, because we can use relativity to kind of time travel, but not really. Basically, like there's this idea, there's a thought experiment called the twin paradox, and it's the idea that like you have one twin that stays on Earth, another hops in a rocket that's moving close to the speed of light, and it makes this trip out to the outer reaches of the solar system and then comes back. And when the astronaut twin comes back, they're still pretty young. But for the twin that stayed on Earth, it's been like 30 or 40 years. And this is due to this concept called time dilation in the theory of relativity. So as of right now, it doesn't allow you to really travel in the past. Relativity just makes it so that your rate of time change is different from another a person in a different reference frame. But I'm glad you brought up the thing about the International Space Station, because you can not only, within relativity, you can not only change the rate at which time flows for you by moving really fast, you can also change it by how close you are to a gravitational field. So like, remember in Interstellar, they went to go travel to that one planet with the big waves on it and whatnot, and it was closer to that black hole, Gargantua.
Oh, yes.
And so what had happened in that movie was the crew that went to this little planet came back, and for them it had just been like a few hours. But for the guy who was waiting for them on that space station, like it had been like 30 years, which is true. Like that's a totally proven thing within relativity. But then that brings me to the point you made about the astronauts in the International Space Station. Time actually ticks at a slower rate for astronauts on the ISS because they're further away from the center of gravity of the Earth.
Which is super neat to think about. And again, I think like that whole concept of time travel looks very differently from the scientific world and the science fiction world. And they take, again, just like I was saying, science fiction is built off of some kind of concept in science.
And they're always borrowing from each other.
Of course. And we've talked about that before. So I think I have a lot of questions when it comes to obviously the concept of the casualties. So like in Loki, you have the TVA. They are monitoring to make sure that there aren't people breaking the timelines too often or impacting the timelines too often that it kills off a timeline, right? Which is obviously a very interesting concept. But you do have scientists and physicists that are studying for casualties when it comes to how we're studying current concept of
Mm.
relativity and all of those things, wormholes, they're monitoring. Because obviously that's a casualty thing is a thing. We don't want to risk millions of lives for some chance to time travel.
We don't want to cause an incursion.
Like the
in,
grandfather
the Doctor
paradox.
Strange universe, yeah.
Yes, like the grandfather paradox, though.
Well, yeah, the grandfather paradox, yeah, that's a really good example. It's like if you hop in a time machine and you go back in time and you accidentally kill your grandpa, what happens to you? Because your grandpa doesn't exist anymore. So therefore one of your parents can't be born. So like you can't be born. So do you just like fade away? Or I prefer this interpretation. What if the universe in which you killed your grandpa, you continue on, but you split off into another timeline, very much like Loki.
I do think, I think it would be interesting, just that whole realm of like, what if Beethoven could take Beethoven's written music to him and say, here, and then he writes the music.
Yeah.
That concept is the same type of
it would be an infinite loop. So like who actually wrote Beethoven's music in that paradox? Paradoxes everywhere.
It's mind-blowing, truly. Yeah. So tell us about how you feel about time variance, how you feel about the time travel, where we are. What would you like to do if we did figure out a way to time travel? We would love to know how you feel about that.
Yeah, let us know in the comments, and let us know like what period of time would you travel to if you had a time machine? Would you travel to the past at some point, or would you travel like way into the far future?
All right, we'll see you next time.
See you guys.
Thanks for tuning in to STEM to Stern. We hope today's episode got you thinking. If you enjoyed the discussion, subscribe and share it with others. And be sure to check out our show notes for free resources and links that go along with today's episode. Until next time, keep questioning and keep exploring, STEM engineers.